Today, as Arman mentioned, we will dive into testing. So far, you already created your backend services, and you already replaced where you store the data to the MongoDB. So you achieved so far a lot. And then, like, this is a really good time to check your code and like increase the quality of it. So today we will talk about testing. But right before that, I will add a little bit more about myself. Yeah, on top of what Arman said already. I'm Miri. Some of you I know from last year, and some of you are new. So it's good to be here today. It's great. And also, like, I want to tell a bit about myself. I'm coming from Turkey, Istanbul. I studied computer engineering, and after that, I worked on several different platforms, with several different programming languages. So, including Oracle databases or .NET Web Services, and then I moved to mobile application development. And then mostly I worked with iOS programming, but then like 5 years ago, I moved to Berlin. And then since then, I'm working with Cordova apps. Like we also have this full stack approach within our team. So we also work on our backend code like you will do actually. This JavaScript crash course is kind of unlocking you to be full stack as well, because you will learn backend, but next to it, you will also learn next week front end. Anya will present. Yeah. So in the end, yeah, that's all from me. And now I'm working with some of the instructors here as a head of mobile engineering. And yeah, like that's all. I think, yeah. And maybe I can mention that like I worked on some banking apps before, some e-commerce apps. Some of them are worldwide known, like ING Bank or an eBay project, but also some local projects like in Turkey. So like I can say that like I released apps which were used by millions of users. So that's like a good experience, and I also think that's a good reason that I'm telling about testing actually. So we can start. Oops. That was a sneak peek. Why do we need testing? Like, I think among you, there are some people who are familiar with testing already. I know a few people. So I would like to first know about you, and like if you have something to tell about your testing experience. Is there anyone like who would like to share why do we need testing? Sure. Do we need microphones or? That's good.
For flight, right? So, or in the medical industry, right? And if we have errors in our code, maybe someone is dying, right? Or
That's true.
A little bit brutal, yeah.
yeah, playing. Also, the plane can crush each other if we have defects in our code.
Yeah.
But also, if we are making software products for making money, right? So if we have bugs in our code, will be not money, right? And will be the company will be closed.
Yeah. That's like
yes, that's
yeah. That's a very good but very brutal start actually.
Dystopian future.
Yeah, I was expecting you to share your experience from last week's, because you already actually everyone in this room, like not the ones who just came today, but you all have experience with testing, because whenever you were writing a new service, you were trying it out. you were testing it, you were not writing an automated test, but you were testing what you built already.
Manually.
Manually, like, or using on browser Axios and
console log
and checking like if you can really create a person. But of course, that's really important what you said. Like we should code responsibly. That's like a motto we should have, and like it can lead to lots of, like, if it only leads to money, that's the best. You know, it can lead to lots of other issues like self-driving cars we are talking about now, and or also medical industry. Like
she already gave the worst examples.
Yeah,
They were the best ones.
Yeah, but let's start
People
with like
can
you
die.
want to create a person, but you want to ensure that you can create it. So that's like the simplest, and that's the test that you all wrote actually already. So if there is anyone else who wants to share, like for instance, I know there are other like professions here, professionals. So it could be like a PM or a QA engineer also testing an application. But also you may work at a marketing team and you are checking if the product is working as it should work. So these are all a part of testing. And I summed it up in 4 different categories actually, so that like our brains work better with categories. It's easier to understand. But yeah, these are just like some abstractions. So we can start with like human errors during development phase. As I mentioned, maybe when you were writing your code, you were making a mistake, or like, because we are all humans, that's so normal that like during the development phase, we made a mistake. That's why we always write tests or manually test the things that we write. But what is the reason that we have these errors? Like, why do we write wrong code? It could be because like we have a lack of experience in general, but it could be because it's a new programming language and we don't know how it has to be done. It could be a very complex algorithm, but it could be just because we are human and it's a bad day, or there's nothing related to seniority as well. Or maybe you are so much experienced, but you need to use the code which is built by another person, and maybe that person made a mistake. So you need to write a test, even that's like a joke that like if you are God, you shouldn't write code. But unless you are not, you should write the test. Sorry. So this is like the during development phase bugs, and we need testing. But it's not just about like the quality about the software, because like here we care about software, and then we say like, oh yeah, I will use the best framework, I will use the newest technology, I will use the best programming language, right? Like this is how developers always think. But then in the end, what we create is a product actually. I'm working at an electric scooter company. Okay, I'm using lots of good technologies here and there, but in the end, the scooter is the main product, and the application is a product which is also extending its usage, right? So I should always keep this in mind, that even I use a very complicated architecture or like very advanced level of programming, the most important thing is that like we do a reliable, stable, high quality and high performant product. And this is not always just because of software. So it's always like having other kind of testings as well. So you need to test your product if the user is using it without any confusion. We were talking with Ömer, like Ömer also presented a session here a few weeks ago. And we were talking that like he mentioned about an article that he read. The patience of internet user is only 4 seconds. So they go to your website and they check, and if it doesn't work in the first 4 seconds, they just refresh again because they think maybe my internet is, shitty. But then if it doesn't work again, they never come back. So this is just this 4 seconds that you have to make it work. Maybe you did lots of engineering work, but it's not performant enough. So there are tests that we should write to ensure that as well. That when a user comes to our product, we should never lose them, because there are always competitors, and there could be always another product for your user to choose. And yeah, next. It's the decreasing the maintenance cost, or like also the early detection of the error. So like sometimes this is the question, like for instance, Facebook, you haven't, like somebody built Facebook, Mark Zuckerberg, okay. And then like he didn't stop, right? Like it always grows and grows. Maybe you will have your own projects, and even you don't want to add any feature on it, you have to go on doing maintenance work, because there will be a new browser version. There will be a new Mac OS version, or like operating systems are changing, devices are changing. So even you say that you don't want to add anything on top of it, you always have a cost of maintenance. And then this always happens that like you have an app, everything works fine, and there's a new iOS release and your app doesn't work anymore. So if you have a testing which is automated, you can detect it before users even see it, because you would run this test in a new device, new version, and you would detect it, and you wouldn't lose so much money because like maybe your users are gone, because it's not, your app is not working on iOS 13. So that's the third one. We are coming to the last one now. So this is...
Wait, is there a question?
Yeah, sorry.
Just a second. I need to hand this over to you.
So I worked in customer service for a startup company, and we had an app, and it had often bugs. And then these, like, I don't know how, if they do you need to test before every update of the app, or like, because sometimes they just updated something and then it wasn't working, and I don't know if they tested it. Is it possible not to test it before?
Yeah. It could, like normally, of course, actually the fourth step here is directly related to it. If you have continuous testing, whenever you release something or whenever you add something on top of your code, or even you didn't change anything, you always have this testing strategy. So it could be that like you don't even release a new app, but your app is running on different platforms. When there's a new browser, your website is already tested. I don't know what happens in that case. There could be several reasons for it. But yeah, I mean, bugs are always there, but manually testing is taking so much effort. And just think about like how many devices you have, how many different varieties of operating systems. So this is like multiplying it many times. So that's for that you need to have an automated testing strategy.
And you can go back to your developers and ask why they're not doing their jobs properly.
Yeah, that's also good.
Because this is what we get all the time from our business stakeholders, right? As engineers, you're always challenged with the quality of your product that you developed. People are always like, this isn't working. Why isn't it working? Why didn't you make it work properly? And because they're also right. Like a lot of people are calling customer service when the app isn't working and then yelling at them about this. And in the end, the developers are kind of to blame. This is why we have this lecture. Most of the time, in most companies, testing is regarded as optional. Like, it's good if you have it. It's like a best practice. But in fact, it's not optional. Quality is not optional. You have to have a very high quality, reliable, stable product in order to service your customers the best. That's why we have this lecture here. And by the end, you're going to see when we talk about the homework what we mean by quality. And we're trying to instill a sense of engineering that incorporates quality assurance in it. So every engineer should be able to not only test their code, but provide their application and feature, in such a way that it's automatically testable, so that you guarantee that it won't break in the future. Almost like you buy a phone and its guarantee is like 2 years. You write a feature, it should have a lifetime guarantee that it won't break. That is the level of quality that we will be aiming for.
Yeah, there are even these kinds of quality assurance can be even a part of a contract. So for instance, like you are getting a third-party API service, and you can say if the server is not responding, let's say a few minutes, a month, my contract will be cancelled. So this is something which is even in the contracts. People can shut down their, companies because of that, just because of that, because they didn't provide the quality that they
promised.
Yeah, promised. Yeah. Okay. So the last one, we already came to there about like this shouldn't be only before you release your code, but it should be continuous testing. One question here is important, like what makes a product successful? There are lots of answers for it, but like one of the really good answers for it is that it's the speed to the market. So you can, if you can be sure that you can release new features to market really fast, this gives you a really big strength. The reason for it is that like, now I gave the example of Facebook. I can give again, like we can go with it. When Facebook was there first, it didn't have many features, right? It just had like maybe adding a friend, and then it started giving the opportunity to share some photos, and then there was like button, but now there are lots of different emotion buttons there. So Facebook is always changing how they like they add new features or they direct their product based on the users as well. So every week you see that like maybe tens of applications on your device is having a new release. It's because like users are changing, and then you should adapt yourself to release frequently. So that's like a new way of product development actually. Like when you think about it, 10 years ago, a website changing themselves was like every a few months, maybe once a year. But now every week it can almost change completely. So in the end, that's very important that you are not afraid to release something. That's why you need continuous testing, because this is like a fact in our lives, like for developers. That's a big thing, because like on Fridays, nobody wants to release the code because the weekend, you don't want to work. But if you do continuous testing, and if you ensure that all parts of your code is tested well, you are not afraid to release code on a Friday, because if there was an issue, you will detect it even before. So yeah, this is not good. And in general, I don't know, like there are lots of test names there. Some of them maybe you are familiar with. Can you tell if you are familiar with any of them? Unit testing. Yeah, and manual testing, of course. Like, because manual testing is like what you did as well with Axios. So this is like what is happening in real life and what it should be. So this ice cream cone is an anti-pattern, and we write really less tests. In the end, we need to manually test our codes. But of course, this takes so long time. But if you would have written lots of tests to test your units, to test how it works together, to test from the start till the end, then you would only have a few manual tests that you should do. So this we will come back because we will deep dive into these tests as well. But I just wanted to say in the end, when you write tests, it already like takes the burden of doing the manual tests. Have you heard about test-driven development? This is like this fancy way of development. Maybe you heard it's cool. TDD, yeah. So this is like normally what we do is we write the code and then we check it if it works. And then maybe we also write and cover our tests with unit tests, as you mentioned, or with other tests. But test-driven development is like you don't write the code first, you write your test, and then you write the code based on your tests because you expect your test to pass. We will come to here and we will try it in a minute. Okay. So the pyramids bottom part, as you know, unit testing. What is unit testing? Like maybe if you know.
Wait, I have the mic for you.
Well, you test if the model methods work, I think, like a single model methods.
Yeah. So testing, we know. Unit testing is like testing a unit, like a module or like a piece of code which has a responsibility of a single job. For instance, you have maybe you have a function which is doing the summation of like two numbers, and then your test is just testing this little function, this little unit. So it's like a unit of the code, a standalone function. And how do we do it? Like we give it, we call this function, this unit, with an input, and we compare the result with the expected output. And the example comes. I think it will be much easier with an example, and we will work on this example as well. So when you just check the structure here, we just have one function. It just does, it gets two inputs, variables, and then it just adds them. And the test we write is that we say we are expecting sum of 1 and 2 to be 3. So the actual result is how we call the function, the expected result, and then T is just comparing the actual result with the expected result. And if it is equal, your test passes. So this can sound a bit alienish, but we will step by step implement this together now. Okay.
So let's start with the definition of a unit again. A unit is the minimum amount of code that does something, anything. It can be a function that adds two variables. It can be a function that prints the name of a user, like printing name tags for meetup attendees, right? That's a minimum functionality. There's no clear definition of what a unit is, and per project or developer it changes. But ensure that it's the minimum amount of functionality that makes sense to test. So it shouldn't, by definition, involve a meetup and a person. Like attending a meetup is not really a unit test. It is referencing two different modules, right? You have the meetup and the person. But a unit is, in this case, could be an addition, or again, printing the names of the attendees of a meetup. So by building your tests around these minimal structures, you hope that they give you confidence that your entire application will work. Your code is built up of these little blocks, like Lego blocks, and you make sure that you produce those blocks correctly, which gives you confidence that in the end, when you put them together, you will have a very beautiful castle or a car or a spaceship like Lego. Or will we have that confidence? Will be the second part. But before that, let's jump into unit testing.
So I wanted to start a new project with you together because we mentioned about test-driven development. And we said that we won't write the code first. We will first start with the tests. So for that, let's create a folder together with make dir comment. Is there anyone using Windows here?
Probably. Okay.
You can also, I think it is the same comment. It's the same comment.
Okay. Check how you create a
But you can also create a folder manually. And our instructors would help you as well.
Yes.
So we create the, oh, yeah, I already have that. Okay. So this is creating a folder. And then we should go into the folder with change directory. So just create a folder and go into the folder. And you already know about NPM packages and you already created before, but let's do it again for us now. We create a new project now.
Yeah, maybe we didn't cover npm init. Npm init is the command that you run to create a new project, a new Node.js project that gives you pretty much everything you need to start developing Node.js applications. It asks you a couple of questions, and
we will just
press enter and accept the default values for those questions. And in the end, it will leave us back at the command prompt so that we can actually edit our code and create the application.
Yeah, as you can see, entry point is by default index.js, and test command, we left it empty. We will come back to this. This is like how you want to write your tests, run your tests, that command. Okay, so we just say enter, 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 and if we just open the folder, we will see that it's just like a file, package.json.
Again, the command is npm init. If you couldn't get it, raise your hands. We're going to come over and help you out.
Maybe I just also write it here. Is it small?
I think you can zoom in.
Huh?
You can zoom in with Command plus.
I can't? Okay. Then let's just open a text.
Anyone who needs help?
Okay, this is what we did so far. And we can open the folder we created with Visual Studio Code.
Anybody needs help? Raise your hands.
Yes, so.
Cool, we're all good.
Okay, so let's check for package.json a bit. What is inside of it? Okay, so by default, it's the name of the folder, and it gives a version. And as I said, there is a command here. We didn't do anything, so it says no test specified, and that's all. So to be able to run our tests, we will use today Ava framework. So that's a Node package that we can install. This is what you should run. Let's check it out here, like this. And then I press enter. Okay, so while it's installing, we can talk about save dev. Have you ever saw save dev? Because I know that you already are familiar with npm install. That's our Node packages that we use, piece of codes. Yes, yes, it is adding the dependency to the package JSON. It didn't yet, but when this is finished, it will add here, and we will see that it is a dev dependency. So the reason for it is that we don't want to use Ava framework for our code, but we only want to use it for our development process because we only want to use it for testing. So yeah, as you can see, it's a dev dependency, developer dependency, development part. So it's Ava, it's installed. Okay. So as we talked before, we really won't write any code. So before writing our test, so let's open our terminal in Visual Studio. And if everyone is here, like, should we wait a bit until everyone installs? Or if you have any issues, you can ask to our instructors by raising your hands. Okay, so this means we are good. So as I said, I want to run the npm run test command now and see what is going on here. And do you think it will work? This is a good question. Like, do you think it will work or not? Okay, let's have a hope.
Could you zoom in a little bit?
Yeah, sure. Is this good?
Yeah.
Okay, I think we don't need the... Should I also share the comments on Slack maybe? If you want. These are the comments we did so far. And yeah, as you can see, we got an error. It says, error, no test specified, exit 1. So I think we saw this before. It's just here. It gives the error. So why is it giving this error? Because we didn't write our command to run the Ava. So if we just basically here write Ava and run it again, npm run test, now we get another error. This time it's not echo no test specified default error, but it says it really couldn't find any tests. So we should start with writing our test now. So let's create a folder for test and add one file for edition test. Okay. So here, I want to write my test. As we saw before in the unit testing example, let's do this one. But I have to import test from Ava. As I said, we are using test function from the Ava framework, and this is where this test is coming from, and T is as well. As you can see, we can reach to its definition.
Okay, there are a couple of things to note here. First, we normally use const something equals require something for importing modules. We use import functionality here. That is not out of the box supported in Node.js. But Ava, if you look at its documentation in GitHub, it's a futuristic test runner framework. So it supports the latest standards of JavaScript and everything that is not available to Node.js yet, which means you can use the latest JavaScript syntax of importing and exporting and reusing modules. And that syntax starts with import. And to make it more readable, we call what we import test, which would be equal to saying const test equals require Ava is the equivalent. We want to be fancy. JavaScript developers are usually hipsters. They're really fancy. They want the latest shiny stuff. That's why we do all kinds of things like renaming Ava to test, right? The module name is Ava. Why do we call it test? Normally, we required chalk. We said const chalk equals required chalk. We were requiring person model. We were calling it person model. Now we're requiring, bless you, now we're requiring Ava. Why are we calling it test? Because it makes a little bit more sense when you read it. On line 3, we say test sum of 1 and 2 should return 3. It would read worse if we said Ava sum of 1 and 2 should return 3. That is the only reason for why we use a different name. And the syntax is something specific to Ava that you need to learn. Like it starts with test. Test is a function. The first parameter is the name of the test. The second parameter is a callback function where you do your business logic. It can be an asynchronous function as well. And we're going to cover that in a little bit. But Ava is not the only test runner. There are multiple test runners in JavaScript which share a similar syntax. However, you will see that sometimes they call it another function. Sometimes it's another object, and you don't really have test, but describe. Sometimes you see nested tests. So every test runner has a different syntax. And as a developer, whatever the company is using for unit tests or whatever tests they have to build, you have to get used to the syntax. So this is just a syntax test. And you'll also see, Miri already mentioned, there's an object called T, where we do T.is. In some testing frameworks, it is a function called assert, to assert that two values are equal to each other. So these, if you Google for testing online, you're going to see different syntax and a lot of different ways of testing the software. So don't be confused about it. There is one way of creating classes in JavaScript, and by saying that I'm lying already, there are more than 2. So it's a standard way of creating JavaScript classes. There is no standard way of writing tests, and every test framework has its own syntax.
Okay, let's run this, and let's see what we will get. So now there is a new error. It says sum is not defined. npm run test.
So that is standard. You're always going to see npm run test. That is the standard way of running our tests. It's a script in our package JSON. You could put anything there.
Yeah, we will put some other examples there as well. So since we are here, maybe do you remember NodeMon that you were using? What was it used for? Yeah, without running it again, it was updating. So there is something for testing as well. So we should add the watch. But for that, to make it work, we should also install. No, for this one we don't need, but for the NYC we will. Okay, so let's just run this. And you will see that this time, whenever I change something here, let's say I say, I want to change the title, it reruns. Okay, so this is like almost like the nodemon way of doing things for testing. So it is watching the changed files, if the file changed, if anything changed, and it reruns the tests. Of course, you can rerun it manually by pressing the R key as well. Okay,
so what we did was we added --watch to the test command in package.json. And as Miri said, if you edit, you don't have to run the tests manually every time again. And whenever you save the file, all the tests will run. So which is already a very good entry to continuous testing. Like, as you're developing stuff, you are continuously testing your code and see if it works, see if anything breaks. You don't even have to run your tests manually, which is really a great way of developing software.
Okay, so now it tells me sum is not defined. Since we are doing test-driven development, we don't even have a function yet. So I get this error. It tells me what I should do next. It tells me that I should define a sum function somewhere. So of course it shouldn't be inside the test anymore. It's a folder, it's a file that I will create for my code. So I call it library because I can add lots of other mathematics operations inside there. But I will start with the sum. So it's the error function definition. And let's just return 0 for now. Okay, and I save it. It's still the same because I should import it here. So I have the definition of library, but I didn't import the sum function. So here, let's do this one. And when we save, we have a new error. We will always have an error so that we can improve our code. That's the whole approach about test-driven development. So what does it tells me?
Can you scroll up a little bit in the terminal?
Scroll?
Yeah, scroll up a little bit. So maybe one more line, because it should already tell you the error that it failed. Yeah. So it tells you that the test already failed. And it tells you what test failed. I mean, we currently have only one test. It's addition. Sum of 1 and 2 should return 3. And then it is showing you in red what line is problematic, line 7. And they're using the library chalk. So you're already familiar with how this is done. We can give a background color to the terminal lines. And then it is telling the difference. It says, hey, we expected this to be 3, but the actual result is 0. The actual result that is returned from the function is 0. So there's a difference here. Check it out. Obviously, it's not a big deal when it's only a number, but when it's an object, those differences will be really crucial in identifying where the errors are.
Okay, so how can we fix our code that this test passes? What do you think? Like, there can be lots of ways if you have anything in mind. So I should go back to my code and I should fix this function so that this test passes.
Let's return 3.
Oh, okay.
I mean, it's expecting 3, right? If you return 3, it should work. Yes.
Yeah. But it doesn't tell. In the case of success, it doesn't give more detail. So to get more detail, you can add verbose.
So we're going to add another command to package.json in the test script. We're going to say ava --watch --verbose, which will give you a little bit more clarity on the errors and everything. I think you need to restart it. So you need to stop the process and restart npm run test. And now you see there's a green check mark before addition, sum of 1 and 2 should return 3. Our function works. I think we can call it a day. We don't have to deploy on Friday. Our summation function works, right?
By the way, we have lots of instructors in the, yeah. Somebody, can you help? Because like I think for every 4 people, we have 1 person.
Yes. Feel free to use us. We're here
Yeah.
to help you out.
Okay, so the good thing is that like we didn't acknowledge it, but we have 1 test passing now. So for the first time, we wrote a test and it passed. But of course, yeah, it's like this. Just 3, because that was what I was expecting. So this is again, like maybe it may sound funny, but then if you go on writing tests, we will, like the next approach is to make your code fail again. You can also do that. I mean, this is like an example. So of course, this starts with the dummiest approach at the beginning, but you are right. We will come to there. But here, the idea is that like you write the test, it fails, you fix it, and then you write another test to make your code fail again. By that, you iterate and you make the code better and better. So yeah, like what would you add? So if we add another test now, I think we can add another test. I will just copy paste this and create another test here. Let's say this time I want to sum 2 and 2, and it should be 4. Okay? So I'm saving now. And this time I see that one of my tests passed and the other one failed. What I did is just copy pasting and, sorry, this should be like this. So in the end, like I expected to be 4, but it's 3. So how can I fix that?
We can fix math so that 2 plus 2 always equals to 3.
Yeah, you can go on each time having different approaches, but math you shouldn't because it's a dependency. But yeah, like as you already mentioned, let's write the sum function now. So can anybody tell me what I should write? Like this? Okay. Yeah. Okay, so this one is working. So it says like A and B, and I just sum them, like add them together. And then now I can see that like my test passed again. Here it's the actual result, and you call it with parameters, and you have the expected result. Is this the question? And I didn't understand.
Let's reiterate again on the microphone so that people online can hear us. They can only hear us through the microphone.
This is the test.
Asking if you can put in your test, like I will make addition, whatever, with a function.
With a function.
Yeah, your test to find the function.
I'm not also following.
But we are calling this function here. Another function, do you mean?
Yeah.
Which function? Like JavaScript functions or math functions?
Wait, let's reiterate it again.
Mhm.
Or maybe we can talk about it after the class in the break.
I
Okay.
will just show you something.
All right.
Okay,
Yeah.
that's
Because I
good.
just I using
Mhm.
Cypress for testing.
Okay.
That's why I asked.
Okay,
All right, we can talk more
we
about
can talk.
Cypress.
Yeah. So, okay, so far we have 2 tests running and successfully.
2 tests. What is the second one?
The second one was that like we added some tutu and then
okay.
it failed because the result is 4.
Yeah.
So
And
we
then we
wrote
fix
the
it?
normal
Okay.
normal function. Yeah. Some function. Okay. So who can tell me a case that my function may behave unexpected? Because yeah. Okay,
Oh.
good. So let's do it like that. Let's say you want to sum. What do you want to sum? Test? Manual. Manual. Okay.
Yeah.
Okay. So what do you want it to do? Like, what do you want it to like? Because we are writing the test, so we expect it to give us a result. What is your expectation from this function to behave? What should it be? That we will do later, because now we write test first and then we will write our code. But here the important thing is, what do you expect it to do? Like, what do you want? Like, what do you think this should return based on your code? So, manual test or test manual with a like this or with a space. Okay, let's see what it will do. It's not important how it will behave. We just have an expectation and we give the input and we compare it with our expectation. Okay? So we run it. As you can see, it is adding them, but without the caps, the space character. So there's no space character in between in the actual one, but we were expecting it to have a character because we want our code to work like this. So what should we do now? What would you do? Of course, as you said, you already started with it. You said that, like, how can I check if this is a string, right? So what you do is you just Google it. You say JavaScript type. Yeah, but we are checking together now. But type of, can you type of? So this is the best resource that you can get, right? It's already it will tell me if it's string, number, Boolean, if it's undefined. So I can just use this. So I say, if the type of A is string. Is it like this? Let's see. I think it's, yeah. And also B is string, right? Or anyways, let's check it later. So I want it to return A plus a space character and B, right?
Whoa. Do not try this at home.
I don't know if this will work, by the way. But if it,
it's going to work, but don't try it at home.
Yeah, but this is the approach that we try to. We have an expectation. Yeah, sure. We have an expectation that our function takes 2 strings and then it returns a combination of these 2 strings with a space character. So you made it work. This, of course, is not the best way because, first of all, maybe you shouldn't even sum them, or you could name another function, or you could create another function just for this functionality. But the approach is this. You have a test, you have an expected way of working, and then you make your code work like that. And as you can see, by this way, you can raise lots of pre-questions. Like you can say, okay, maybe you wouldn't even think about it. You would just say A and B, and it's just A plus B. But then now you start questioning, what if A is an integer and B is a string? What do you want it to do? Do you want it to turn it into a string? Or do you want it to give an error? Or do you want it to maybe just don't care about the number, but just return the string? We don't know it. This is your product. This is how you decide how your code should behave like. So that's why this is a good approach actually.
It could be a Boolean, and the other one could be 0 or null or an object or an array. So it's up to you to decide what that summation function will do. However, make sure you don't add too many responsibilities to a simple function. If you have a summation function, which in the best case is summing up 2 numbers, it should just sum up 2 numbers. Don't try to add an additional case to handle strings. Do them in another function.
Yeah.
There is but this is a great way of thinking about testing. There's a joke, maybe you came across it on Twitter or something, like a QA walks into a bar, a quality assurance engineer walks into a bar, orders 1 beer, orders 2 beers, orders 0 beers, orders a beer and a wine, orders every single whiskey in the menu, orders 0.001 beers, and then a customer walks into a bar, asks for the bathroom, which is something that is not intended as a functionality of the bar. Like the QA tested everything about ordering nothing, ordering multiple items, ordering fractions of items, but they didn't really test the actual customer behavior of, asking for the bathroom, which is very common for bars. So it is used to highlight a very typical behavior from QA engineers or even developers. Your users will always use your product in the ways you didn't intend them to. If you think about it, if you are a barkeeper, you don't want to allow people who are not your customers to use your bathroom, right? But that's the first thing that they're going to do, that they're going to ask. So real life scenarios are never covered in those cases, in those test cases. And it's very difficult to understand what those test cases would be with real users, what they would come up with, which is why we also need a lot of manual testing with users. And these tests are for the remaining edge cases that we could identify. And let's do our job the best we can. Let's make sure we can deliver them half a beer, and then we're going to ask real users to come and test our application, and they're going to ask for the bathroom, and our bar will crash because we don't have a bathroom functionality yet. But yeah, it's a great way of thinking about testing, different edge cases, different types of input. And you see where it's going. Like if you want to be really, really specific and not make any errors, this simple function of just adding 2 numbers will be like 20 lines. Throw an error when this happens, throw an error when that happens. And it becomes, it's not very readable. So there is that's why most of the software engineers don't really care about software quality, because it's a lot of additional work for them. to write these edge cases and to cover them with proper errors and handling. That's why you see a lot of bugs on your mobile phones. When there's an update on every application, it always says bug fixes and improvements, right? What are those? You have 2,000 engineers. Why do you have so many bugs that you have to fix them every single week? Because we don't do this. It's very hard to write those lines. We don't want to think in negative terms as developers. So we always implement the happy path, and then it's up to the customers to be annoyed when they find out that the application isn't actually working as it should.
Yeah. So also we could choose to not to run if these are strings. We could say, okay, I'm throwing an error. That's also possible. But I think like asking these questions are really important. Like this tester going and asking for 0.001 milliliter of whiskey or whatever, that's really important, because this is the numbers that we will play with, right? Like we will, when you are testing, you should always have these edge cases. If you already tested 2 plus 3, you don't have to test for 3 plus 4. It will work the same. But what if the number is so big? What if the number is negative?
What if the number is fractional and that won't work? That is the deficiency of math algorithms in JavaScript.
Yeah.
You cannot
Let's try
add.
it.
We can try. You cannot add 1/2 and 1/3 and 2/3. I think it doesn't return 0.3. I mean, we tried this in the first class. They fixed some of those issues, but not all of them. So if you tried with large numbers like 2000.1 and 2000.2, yeah, see, there's already a difference there. So this even doesn't work. 0.1 plus 0.2 isn't 0.3. It's 0.3000004. We can conclude that JavaScript doesn't understand numbers. It cannot really sum numbers. And there are, you wouldn't believe me, but there are real life libraries out there that are trying to fix this with JavaScript so that you can actually really add up numbers, like 0.1 and 0.2 will add up to 0.3. But yeah, software is complicated. Even JavaScript cannot add numbers. How can you expect software engineers to do a perfect job and come up with the best software? We can't. We're human beings. Even machines fail at mathematics. So testing is really important, and it's very difficult. That's why we all have to do it.
Okay. So how do you think we can fix this? Like, this is again like almost like a product decision making. Like you can say, okay, do I really care about this 0.00004 there? I didn't say enough zeros. But if my product or my function, for it matters that this really tiny difference is really important still.
Maybe. Yeah, what if you're doing Bitcoin?
Yeah.
That fraction over there, would probably cost a few dollars.
So, like, let's say that we don't care. That's the easier way of iterating, I think, because otherwise we may need to use advanced techniques. But let's say that like my function, my app is Meetup app, and I will use this function to charge the ticket prices. So if I will charge this money to the users, it will be in the cents level, right? So cents is like only 2 characters after the dot, like 2 digits.
So 100 cents is €1 or $1, and we don't really have a third digit there.
Yeah.
So it's always like $5.99 or something, or $4.99.
Okay. So if I say that my function should just care about 2 digits after the dot, then I can find a solution for it. So the easy solution, it's related to the floating points representation. So that's why, like, if we multiply it with 100 and then later divided to 100, which is basically like multiplying and then dividing again back, it works. Because then it becomes 1 and 2, and my code can, like actually JavaScript, can sum 1 and 2. So that works. So
it becomes 10 and 20. We sum them up and then
yeah, 10 and 20, sorry.
So and 30 over 100 is 0.3. That's why it works.
But of course, this wouldn't work for the case of, again, this one. Because then it's again the same issue, right?
0.001 plus 0.002 should equal 0.003, but obviously it doesn't.
Yeah.
Because the underlying engine is terrible at these operations.
But as I said, I don't expect these numbers. So I don't have to cover these cases because my application is only dealing with money. So for that, cents level is enough. So I don't go on multiplying it with, 10,000, 10 million. So I can do that as well, but it's not needed in this case. So since this...
Questions so far? A question? Could you?
It is
summing
fine.
Okay in my case.
In your case, summing works?
No, it's summing like it's supposed to sum. Like.
Yep.
I don't have any.
So it's numbers like 0.3 plus 0.2 can add up to 0.5.
Yeah. It's just about 0.6, like 0.4 and 0.2 also doesn't work, but 0.3 and 0.2 is working.
So some numbers work, some numbers don't. It has something to do with how JavaScript represents these numbers in memory. Because, computers don't know numbers. Computers know ones and zeros only. It's the electricity is either on or off. Everything that we do here, every pixel on the screen is represented by ones and zeros in a certain way. So there's always a translation. There's always a representation. And in this case, numbers aren't really represented well. They don't really translate very well into ones and zeros, especially fractional numbers like 0.0 or 1.5 or something. They don't really translate really well to ones and zeros. That's why computers cannot add them, because as you would guess, computers can only add ones and zeros. They cannot add other numbers. And, they only work in binary, is what we call them. So in ones and zeros, 2 digits only.
Yeah, so if there are no questions, we may move with the integration testing.
Wait, are there any other questions? It's pretty much important that we cover this bit, both in code, in terms of code, and in terms of understanding. Any questions? Please. Just a second.
Hello. Okay, I did pass in the end. All right,
Okay.
I just got confused. It's all right.
Yeah, no. I just put it back like 0.001
I was going to ask if
is
we
not
can
working.
use like the number prototype and like methods on that to control the number of decimal points.
No.
That won't work.
The question is like, can we use
Plus
number
operator.
prototype or fix it in a certain way so that we don't have to do this
but
magic
then
all the
doesn't
time?
matter.
And no.
Okay.
It's not even on JavaScript level. The JavaScript parsers, in this case Node.js, the code inside Node.js doesn't know about numbers. So anything you do on the JavaScript side, client side, will not fix it. That's why we need magic like multiplying it by 100 and then dividing it by 100. You can read the source code of certain libraries on NPM. There are, I think one is called big int for big integers, big numbers. And then, you have up to 128 bits of numbers, which is like trillions of numbers. You can see how they do it in their source code. It's very complicated, and it's not fun. Adding numbers turns out it's very difficult and it's not fun at all. That's why we kind of say, okay, this is enough for us. We don't really care for the future. What? But adding numbers is hard, but machine learning is not. Anybody interested in machine learning or data science? Raise your hands. It's fine. So dealing with numbers, classifiers, machine learning models in JavaScript actually works. So even though it looks like JavaScript cannot add numbers, it can crunch numbers, and it can actually run very, very sophisticated machine learning algorithms. So that bit works. Don't worry about it. JavaScript can do math. You can do everything you would do with Python or any other language, for that matter. Even MATLAB, which is a scientific computational language. JavaScript can do all of those. It sometimes cannot add two simple numbers. But, you know, all of us have their quirks. That's fine. We still love it.
Okay. So we can now go to our presentation again back. So
should we take a break?
No.
No?
No, because we will, on the second half, we will work on end-to-end testing. And I checked, when do we, like, I think in total we do this presentation for almost 3 hours, right?
Yeah.
So it's not half yet.
I know.
But if you want, yeah, of course.
Let's take a break for 10 minutes and then get back. Maybe let's say, so right now it's 8:11. Let's get back at 8:26. So let's have 15 minutes of a break.
I think we now have this understanding of how unit testing should be written and what is the reason. And then if you, like, we will move with integration testing now. So the name tells again a lot. So far we tested our units, but we didn't test how these units work together. So you can think about integration testing that, like, different systems working together or different piece of code working together. And there are some examples actually, like 2 unit tests, 0 integration tests. So
this is great. So individually, the windows are working, right? This was what I was saying. You can write as many unit tests as you want, and you still won't have 100% accuracy on the quality of your code or your application. It won't work. You know, when you put them side by side, they just won't open. So whoever installed these to Windows didn't really have any ideas like how these would be working. This is why integration testing is really important. Even if you have 2 of the same thing, windows, in a different configuration perpendicular to each other, you still have to bring them together and test them.
Yeah. And here is another funny example. They work, but when you do the integration test, it's not supposed to work.
Wait, what is it?
It's
no, it's a sliding door. It's a lock on a sliding door.
Yeah. I will do.
So the door works for sure. The door is doing its job. The lock is also doing its job. But together, they just don't work. Yeah. Again, this is why it's very, very important to make sure when you're testing something, you're looking at it holistically. Not only do you make sure that the door or the lock works, but you also have to make sure that they work in conjunction, in a context. And, you know, normally people put these on different doors. Nobody had the idea to put it on a sliding door. But then you have this customer who walks into a bar and asks for a lock from a bar. and puts it on a chair and then rolls the chair around and stuff like that. You know, these things will happen in real life. So that's why I'm saying it's really difficult to have to keep an eye open for these things. And that is exactly what we have to do.
Yes.
In order
Okay.
to do our jobs better.
So for integration testing, you can also think about like while writing your test, when multiple parts of the code is working together, you may need to put some dependencies in a box, kind of like. Have you ever heard about mocking? Like what the term mocking?
Is it
what
making
does
fun
it
of
tell
people?
you? Mocking, yeah, could be. What does mocking mean? Mock. Yeah, exactly, like faking. And in some cases, when you write your integration test, you may need to fake some parts of the code. So for instance, like you can have a database, but then when you write your integration test, you can mock it. You can mock your file system or web services you call. And we have an example for a third-party API now. So
wait, could I ask you to go back to the Windows slide?
This one.
Yeah. So on the left, you see there are two live systems out there, two windows that you can open, and you can see they don't work, right? In order to test this scenario, you don't actually really need two windows. You need one window that you really want to test if it opens or not, and you need something else that is in the shape of a window that blocks your window, right? Because at a given time, you're only opening one of those two windows. The other one is static. It's sitting there. It's not doing anything, which means when you're testing it, you don't really need two different windows. You can have one window and something that blocks your window to test the scenario. And that is exactly what mocking is. When we have two different systems that are supposed to work in conjunction, that are supposed to work together, we have the real system under test, and then we have fake ones for the other dependencies, because it's a little bit expensive to have two windows. If you want to test and sell only one window, always having a spare one to test it is a little bit difficult and then expensive. The same with databases.
Yeah. So so far at this course, we were working on meetup example, like our project is creating a meetup. And then let's think that like our product manager asks us to develop a feature, or our product manager is us, and we say, okay, let's have a good emoji when the user comes to my website. If the weather is warm, I want to show a sun emoji. But if the weather is cold, I will show a snow emoji. So I have a dependency here. When you think about it, since I'm a meetup application, or I'm working on a meetup application, I don't have to work on a weather application myself. I can use it. There are lots of weather APIs like Google has or AccuWeather has. So out there are lots of third parties that you can use and provide some functionality for your users. So here what we do is normally we check the weather API, we check the weather today, what is the weather, and then if it is 35, we show a sun emoji, and if it's like, let's say 5 degrees, we show a snow. And then how do we test it? This Sinon is to mock the weather API. So whenever there is a call for get temperature to this API, I return 35. So this is only for this specific test. I say whenever there is a call to weather API, I will mock it, I will fake it. And I will say it's 35 degrees now. But when you think about it, if you would wait for it to be manually tested, we would have to wait for summer. And that's not good. And in summer, maybe we would show a snowflake to our users because we never had the chance to test this. So we should test this even before with some fake data. And that's true that, like you said, faking it. And even the terminology is like that. It's stubbing, and then it does a fake call, and it gets the temperature as 35 degrees. And then you can compare. And what does this test? This test, when the weather is warm, my app is working correctly. And it shows a sun emoji. And you can increase the test, of course, for different temperatures, and you don't have to care about the dependency to the weather API. You can just mock it. Does this make sense any, or is there any questions? For like the terminology is not so important. Sinon is used like it's like Ava again, or Mocha or any other framework that's used for stubbing the APIs or faking the APIs or any function. So you can mock your dependencies.
Any questions?
Maybe this.
Oh wait,
yeah.
I just retweeted something this week. That was very eye-opening for me. Instead of asking, "Do you have any questions for me?" I'm gonna start asking. I made a mental note of this week. I'm gonna ask, "What questions do you have for me?"
Oh, okay. What questions do you have for me?
To change the context a little bit, because we know everybody has like tons of questions, thousands of questions about anything we tell. So the question isn't, do you have any questions for us? The question is, what questions do you have for us? Who's going to be the first? Please, question.
The stub.
Stub is stubbing the function.
What is stubbing?
Yeah, like instead of running it, instead of calling the real weather APIs that function, instead of that, is calling my function here. You know, this async. This is a function that I wrote, and instead of calling weather APIs get temperature function, it is calling my function that I created.
So it might be a little bit confusing. So let's unwrap this a little bit. The function that we want to test here is the third line from the bottom. Const weather emoji res equals await meetup app dot weather emoji. That is what we want to test. We want to test if our weather emoji function returns us a sunny emoji when the outside temperature is 35, right? That is the only thing that we're testing. However, apparently that weather emoji function is calling an external API called the weather API. It's probably the source code of that weather emoji is weather API.getTemperature. It's await weather API.getTemperature to get the temperature of the current weather. And depending on the current temperature, it's returning either a sun emoji or a snowflake emoji. Okay, so what we're doing here is we are mocking the get temperature function that weather emoji is using. We're not changing weather emoji itself. We're not changing the source code. We are changing what weather emoji depends on. We're changing the dependency of weather emoji. And we say, okay, from now on, weather API, when you call the get temperature function on the weather API, you're going to get an object that says temperature is 35. Okay, that is the only thing that we're doing. That is why we're stubbing it. We're saying the weather API isn't a real API anymore. We overwrite the get temperature function to return a temperature of 35. And that is what the weather emoji is using. Would it clarify the situation of stubbing and what we're doing here a little bit more? No? No, I see a head shaking. Okay. This is important. This is really important to get right on integration testing and understanding how we test our dependencies. So let's discuss this again. Here's the microphone for you. If you'd like to clarify the question.
No, I don't understand.
Okay, you don't understand anything. Great.
You didn't understand.
That's perfect.
Okay, so maybe
a more specific question, please.
With the microphone.
Yes.
So is the call fake async temperature 35
added in the so actually it's the opposite question. Is the rest of the code except that line the code we have in the code, and that line is added in the test? So we copy and paste what we have in our code, put it in the test page, and had this line.
This is I think it is a good explanation. I think this is not a question but an explanation, I would say. Really?
Exactly. Okay. So what we have here, meetup app.weather emoji is a dependency. Think of it as the database that we had. We were calling the database that save operation, right? And then internally it was saving to the file system. Do you remember those first initial weeks? Maybe you weren't here back then. Initially, in the first couple of weeks, we were using a file system to save our records, to save our database. But from index.js, we didn't see the source code of that file, that write sync. If you remember, write sync and read sync were two functions that we were calling. We were not seeing it from index.js, right? That was a dependency. That was an internal dependency on our databases. And this is what it is. Weather emoji also has internal dependencies that we don't see. Some developers somewhere created a module called Weather API. It has a method called getTemperature that is already in our code base. That's a module someone else wrote. And then, as the developer of the Meetup app, I'm writing this function, meetup app.weather emoji, and I'm depending on the getTemperature function that is hidden from you right now, that you don't see the code for. Because it's an internal dependency. What did we say before? Dependencies are very expensive to test, right? In this case, if we had the real weather API and real getTemperature function, it would return the current temperature, which is 7 degrees right now. It's going to be, up to 30 degrees until August. Maybe if we're very lucky in August, we're going to have one day that is 35 degrees. So we can never test this thing. In order to test it, we have to fake it. Okay, fake it until you make it is, very cliche. And we're saying that the... Okay.
I will do this.
Oh, write the code for it.
This
Great.
Or
Live
whatever.
coding.
This is like a pseudocode, so I don't have to execute. And our weather API is actually an abstract one as well. But let's say that we call other APIs get temperature here inside of my weather emoji. And then I have this const temperature. And then based on the temperature, I return back the sun.
Maybe temperature over 30 or something.
Yeah. We will do that. And then let's say if it is, then I get a
something else.
Crying face. And I have to, or maybe like this.
Crying faces are really hard to make.
Wait, how do we do it with this, right?
Yeah.
Okay. Or maybe with this would be even better, right?
Anyway, so weather API.getTemperature is an external dependency here. Maybe you can also write import weather API or const weather API equals require weather API. Yeah. It's another module that we're loading from somewhere else. It's a dependency, and we don't want to test that. We just want to test if our function is working correctly or not, given correct weather conditions, given the perfect weather conditions. Is our AccuWeather, yes.
Yeah, so what
is it a real thing?
AccuWeather is a real thing, and they have lots of APIs.
The API Node.js package, can I just install
I don't
AccuWeather?
know. But maybe there is, I don't know.
Okay.
But yeah,
Maybe.
let's say that like here, we have a function, and this is our function. It's our responsibility to test it, okay? And based on different results coming from the weather API get temperature, I need to do an action. So this is called business logic. So there is a business logic here. If it is bigger than 30, it is, and let's do it like this, or maybe else. So there is a business logic here, and wherever you see an if else, this means it can be tested. So to cover this 100%, you also need to have a test, at least one more test to test this case. So to be able to do that, you have to mock your get temperature, like the weather API's get temperature function, so that whenever your code is running, it is running in a sandbox. And then within that sandbox, it's not going to the real function of weather API. It's not going to the get temperature function of weather API, but it is instead faking it. So I'm running this weather emoji in a sandbox, in a different environment in a way. And then there, whenever weather API is called and the get temperature function is called, instead I call this function. So if I would write another test, I would fake it with another value. I don't know if this made a bit more sense, and is it an answer to your question? But here, if I would reach another function from weather API, that would be the real function. Let's say weather API also has another function, which is
get humidity.
Yeah, get humidity. That would give me the exact result. That would give me the exact function, how it was written by the API. Here, I'm just mocking only one function because my dependency for this business logic is the value that I get. Does it make sense any, or what kind of questions do you have for me? What questions do you have? You want to ask? Okay. Okay. So I think this this part was not the best, but yeah. Okay.
Wait, let me add to that.
Okay.
This part was very difficult. It is hard to understand. You're doing a great job in trying to understand it. Let me get this straight. Not a lot of developers understand what this is. That is why we have such poor quality in software. Software engineers don't understand anything about this concept. They're all like, I'm going to write my functions. I'm going to import this and run it, and it's going to work. And then nobody cares if it's 35 degrees or not outside. They just tell the product managers or the designers or the business stakeholders that they did it. It's working. But did they really check it? No. Do they have automated tests for it? No. What? It works on my machine is what you're going to hear the most. Because whoever knows what you installed on your machine, it just works on your beautiful, magical machine, but it doesn't work when we deploy it to production, when we deploy it to our servers. Or when the users install it on their mobile phones, it doesn't work. Maybe they are in the other part of the world, in Brazil, where the weather is around 35 degrees right now. Maybe they're not in Berlin, so they really have access to real weather, and you don't see it. Just because you couldn't test it, you don't know if it will work or not. Question.
Yeah, so this, if we do with the real weather API, it checks the weather for the exact location? Or
Maybe.
like, no? Or I don't know. It's just a question.
This is a good question
Yeah.
again. It could be that it is getting, let's say,
A
location.
parameter.
Location, and then I'm setting the location with the coordinates up there. And then I would also
Mock the location
or fake it.
Yeah. So there are very advanced versions of integration testing and faking things.
Mhm.
Obviously, depending on the
Here you can.
yeah, depending on the parameter that you're passing in to get temperature, whether it's a location or something else, the answer might differ, right? Maybe it is, if the location is outer space, you're going to show like minus 150 degrees. So in those cases, we will have a special syntax to cover for different cases of different input parameters. But that's a little bit advanced, so we're not going to go into that right now. It's fine if we just understand the concept of integration testing. Because again, After this course, you're going to go back into the industry. You're going to start working developer jobs. And I want you to remember these concepts. When people are talking about these things, your team leads, your other fellow engineers are talking about these things, you should know, hey, I actually know what stub means. And I know how to mock a dependency, a database. And this is how we should be doing it. The questions you should be asking are, do we have automated tests? Do we have automated unit tests? Do we have automated integration tests? What kind of integrations do we test for? What others are not tested? You know, there with the window, I'm going to go back to that example. With the window, we saw that when you put them perpendicular to each other, they don't really open, right? What about other configurations? What if you put a window before the other one? You know, what if you stack those two windows? What if one is on the ceiling and one is on the floor? Maybe they will open, but they will open like 5 degrees. You know, you won't have the full opening mechanism. So these are all other edge cases that you need to test when you're building an integration of a wall and a window. So, you know, this thing is really hard. It's okay if you don't fully understand the actual implementation. We're just trying to get across the idea of integration testing. Question? Just a second, coming over. Yep.
But what if you want to actually test the APIs, or like if you're talking good?
Great question. We don't test the APIs. We assume they work.
Oh.
However, I mean, we always assume in real life that weather API will give us the actual real weather. This is the same for databases. We don't test every single piece of technology that we have. They're already tested for us, we assume or we hope. That is really important when you are looking into open source modules. You want a very well-tested module because you don't want to fall into traps or mistakes that are very easy to catch with automated tests. But obviously, we will have, you know, in a real production environment, if this is a third-party API that we depend on, we will have another test specifically for that to make sure they are returning the correct response to us.
So the next type of testing is actually giving the answer to you as well. It's end-to-end testing. So if we want to check our whether emoji function runs completely correctly, that like maybe the weather API is down. So if we really want to test it in the real services, real data, real life, then we don't have any mocks. And then we test it from one end to the end. So we call this function. And then whatever the result comes, it's not easy to get an expected result for it, right? Because what will it return? Will it return sun or will it return snowflake? But then we can still have an expectation. We want it to be either snow or sun that could still give us a test because it returns an emoji. So we could test that, for instance, for this case. And end-to-end tests, for instance, are done for third-party integrations like payment methods. So you have a website and you are using PayPal to, like, for your customers to pay with PayPal. And then, of course, you should check it from the beginning till the end if this really works. Because PayPal may also change something in their API, and then maybe it's not working anymore, something break down. Of course, for that, we can't trust every third party we use. We should also test that. So that was a really good question because of that. Integration is mocking, and it's more about like focusing on the parts that I'm responsible, and I ensure also it works with this third party. If that third party works fine, my code will for sure work good. But then, of course, there is another testing method, which is from front end to front end or front end to back end. So with this whole ends, it could be a third party or it could be my own application. So does it make sense a bit more here? Okay, so an example here, and after this we will start writing our end-to-end tests for our projects. So here we have a test for our create new person service. So what do we do here? Oops. So we have a data, a person to create. And with that data, we do a request to our own application. With the post request, do you know HTTP requests, like GET request, post request? Do you recall any other? Do you know any other? Delete. Yeah. Update, yeah.
Update.
Put. Yeah. So yeah, there are. This is the one that we call. It is like a post request. We call it with a body, with the information. So we call the endpoint of person, and we call with this data, and we expect it to run and create a person. So how do we test it? Do you know the server state, like server's response statuses? Maybe you can tell the ones that you know, like 200. It's okay. Yeah.
404.
404. Page not found. Yeah. 500.
Internal server error 500.
Yeah. We all know, like that's good. Like we all know these already. And of course, to check the status is a way of checking your end-to-end testing's result, right? Because you did a call, and if it returns success, and if it is 200, you did the call. So of course, this is a good start. And the next thing could be that with the response of your request, you get the created person. So you can compare the name of the created person with the one you wanted to create, if this really works. So that's a test for it. We will write this code ourselves. So you can either ask any questions now, or we can also move. Do you have a question or no? Okay, good. So everybody already installed the testing week 6 VTM.js.
Yeah, so we're going to go to our repository, the weekly repository that we share class examples. We have a new folder for week 6 there, and we're going to work in that.
Okay, so we are already there. We can open it with the code as well. Okay, so here it's good to see what I changed. What is different than the last week, because I already added the frameworks as an npm package. So week 6, if you just check the package JSON, you will see that we added this dev dependencies. Ava, we already know now. It's the framework we use to use this test function. And then we have NYC. This one is used for the code coverage. We will come up to it soon. And then super test, we will see, like within our test, we use it for our requests. So, okay, then not here. Let's start with some tests which is already there.
So you're getting a lot of tests for free,
Uh-huh.
as an example.
So if I run, we have to go to week 6, yeah.
Yeah.
Okay, and if I run the test, npm run test, you can see that maybe I'm in the wrong
branch.
Wrong branch, yeah. Let's go to this one. Okay, so I'm running it one more time. As you can see, I have less tests now.
We have 4 tests.
Yeah, 4 tests. So I already tested creating a new person, fetching a person, deleting a person, and getting the list of the people. So we will dive into it a bit, and then we will write our own tests. Okay? So create a new person. I have here person to create. So how do I write it? I go to the model of person, and I see that like to be able to create a person, I need to have a name, an age, and meetups. This is very similar to what you did with Axios at the last weeks. So here we created our data, the JSON data. And then we call the person API endpoint with the post request. And then, as I said, you compare this to data. And then you can fetch. Let's see how we do with the fetch. Did everybody install the version and run the tests and get this test running, like 4 of them? Is there anyone who couldn't do it? And if...
Let's work it out.
Yeah.
Again, as instructions, we expect you to clone the repository, the course repository, JSCC 2019, go to week 6 and run the tests. And if you can't, if you haven't so far, raise your hands and we're going to come over. We're a lot of people here. We'll have you covered. Okay.
Okay, please raise your hands if you have any issues, and our instructors will help. So everyone should be able to see this 4 tests passed. Who has this 4 tests passed seen in their screen? Can you raise your hand? Okay, can you help, Jason? Whomever didn't raise, please, yeah.
Raise your hands. I'm free. Okay, coming over.
Mm-hmm. 4 of them should pass. Like here, what you do is like you go to week 6, you do npm install. One failed. Okay, that's good. Then somebody should help. There is one test which is not passing. Okay, so you do npm install and npm run tests, and you should see 4 tests passing. Okay, so can you raise if you can see? You raise your hands if you can see 4 tests.
Okay.
Yeah, can you help?
Can see 4 or can't. What is the question?
Can't. Yeah,
Okay.
can't.
So raise your hands if it doesn't work for you.
Yeah, if
and
it
we're gonna
doesn't
come
work,
over
raise
and
your
help.
hands.
Anyone?
No, if it works, raise your hands. Because
Why?
they don't raise their hands in the other case. That's why.
I think we have a
Raise your
problem with
hands.
raising hands.
Yeah, no.
Generally.
Okay.
And we really want to help you out. So let
Yeah.
us know. Can I help anyone? I'm free. Coming over.
Perfect. Our instructors are checking everyone's screen now. No. Okay, I think we are good. Like, I see that you are getting help. So we can also check fetch a person test. In between, I may show the code coverage. So at the first lecture, we were talking about npm run test script, like how does it work. So here in the scripts, you can add any script with running special commands. So we will use nyc, which will show us the code coverage. I will show it again for the others as well. But yeah, like if I run test coverage here, you will see an extra information. It says for test passed, but it also gives me some other extra information. I ran npm run test dash coverage, and it is the script that we wrote in the package.json. Here, we had the script, and then when we run it, we are using NYC's NYC framework to
Wait,
show
how
this.
did we get into New York?
Good. Yeah, we are.
Isn't it New York? NYC is New York, right?
Yeah.
New York City.
Yeah, we already covered the dev dependencies, and I mentioned here that we are using Ava and NYC for test coverage.
What is test coverage?
Yeah, so the test coverage is like how many lines of code you tested already. So when your tests are running, this framework is going and checking if this line is already went through or ran through, then this is covered. So this is the result, and we can see that like in our all files, among the lines, we are on 75% test coverage.
So take a look at this graph. This graph is really important in telling how confident you are in your application. The tests that you wrote are covering them. So we have a couple of columns here. The first one is the list of files in your application and the names of the files in their folders. And the other ones are something we call code coverage. So it could be here statements, the percentage of statements that you are covering in your code. That is, something equals something else. The percentage of branches that you're covering in your code. If you have any if or else cases, they're going to be here on the second column. The percentage of functions in your code that you're covering, the number of functions and if they are hit or not, or if they are visited by your tests or not. And the last one is the percentage of lines of code that you have in your application that you're covering. And in the end, you see you have some uncovered lines and uncovered line numbers. So what we usually do when we see the scenario, we go into these file names, we open these files, and then look at those lines and see what logic we have there and try to cover those as well. Try to write new tests for those logic as well. So Miri, if you could go to meetup.js, roots/meetup.js, line 13 is uncovered. So let's see what line 13 is line 13 is rendering the details of a meetup. So we don't have any coverage there. Question? The question is, how do we get the table? We run another command for it that's on Slack right now.
I send it on the Slack, yeah.
npm run test coverage gives you this graph.
And,
Go ahead.
Yeah, it is also in our scripts inside package.json, and we are using NYC for as a framework so that we can see this result.
The story of this NYC is very strange. New York City. The first test coverage tool for JavaScript was, for some reason, called Istanbul, the city in Turkey. Turkish developers didn't develop it. It was Americans. For some reason, they decided to call that library Istanbul. And then, of course, another group of people said, okay, we're going to do better. And then they decided to call it another city, and they decided to call it New York City. That is why this library is called NYC, New York City. There is no reason for why it was called Istanbul in the first place, the original one. And there's no reason for why this is called New York City. But then there are a couple of other test coverage libraries, and they continue this tradition of using city names, which is very weird, but it's also fun. Are we all aligned on the idea of test coverage? We have automated tools to tell us if we are checking every single line in our code base, every single if case in our code base, every single function call in our code base, right? And this is going to be in the homework as well, so it is really relevant for you. You need to have this graph in your homeworks, have this code coverage graph, this table, and the goal is to get to 100%. Of course, we want to have 100% line coverage. We want to have 100% statement coverage, 100% branch coverage. That is the quality that we are talking about. If you're developing software, you might have some exceptions. In certain cases, there are very, very tricky lines that you cannot really test, which means you have to change that line. You have to refactor it. However, some teams will set this bar at like 95%. They're going to say, if we have 95% test coverage, it's fine. We are good enough. We trust our application to be secure and running and functioning well, so we're going to release it. However, it's always great to aim for 100%. Always aim for 100%. And what you do is, whenever you're adding new code to this application, our servers are checking this. And if it drops below a certain value, we don't allow your change. Which means you cannot really add anything to our application without adding tests for it. So if you're adding any functionality to our application, you should also add tests for it. You are not allowed to drop the test coverage percentage below a certain value that you agreed on. For my open source libraries, I keep it at 100%. Every single open source library that I have has 10%. 10% coverage is very stupid. Has 100% coverage. And if anybody wants to contribute to my open source libraries, they have to add a new test for it first, so that we make sure we have 100% coverage all the time. Does it make sense? So we're aiming for 100% quality. A lot of the applications that you have on your phone have this. They have automated test coverage checkers that have, I don't know, 90%, 95%, sometimes maybe 100% of coverage. Still, every week we get those bug fixes, updates, right? Because this is not enough to ensure quality. This is just telling you that the test cases that you can come up with are validating that your application is running well, but it doesn't tell you if you were able to come up with every single edge case that your users would use your app for. So testing never ends. Seeing all green 100% here doesn't mean that your application is bug-free. It just means you couldn't find it yet. So you need to write more and more tests. And every time we fix a bug, we add a test for it, which will ensure that in the future, those bugs won't happen again. Because, multiple people are working on the code base, you're fixing something, another developer might be breaking it the next day. We don't have any guarantee that that won't happen. Question?
You know how there are like testing departments, right?
I know how there are testing departments.
Okay.
Yes.
So do they do all the testing, or does developer should developer also do testing before giving it to testing department?
Exactly. Developers are responsible for everything that goes here. This is within our repository. If we have additional testing department, like QA department on top, they're going to have their own test suites that they run. They usually do end-to-end or integration tests, and they have a totally different approach to testing, which I don't know if we're going to talk about end-to-end testing further today. But they mostly do end-to-end testing, like browser automation. Open the browser, load the web page, click through everything, every scenario, and make sure we can make a purchase. It's a little bit different than that. This is what we have to do on our own. Probably on the API level, we should also have a very similar end-to-end test case. Start with the first API call, get the session, get the user, get the product, make sure the user can purchase the product. We should have a test for it. But also, the QA engineers will have their own tests.
Yeah, like UI tests, especially for instance, for mobile. Developers don't write those tests most of the time because like it is running, like it is like an executable file anyhow. It's not the code. They are testing the application, the executable file. So of course they reach the elements there and they click somewhere or they run it in multiple platforms with their automated test, not manual. But UI testing could be an example that most of the time developers don't write tests for it.
And always, your colleagues will try to sneak in code that they don't have any tests for. They're going to say like, hey, I have to make this to production. My product manager is asking me, is pestering me with this request. Can you allow me without any tests? And the answer should always be no. You have to have tests for it before I can merge your code and release it to production. That is the only way to get a certain level of quality. You can never get 100%. That's not even a realistic goal.
Yeah. Okay, so let's check another example, and then we will implement a new test from scratch. So I think we can check the fetch a person function now, like the test. So here our aim is to normally to like what we are testing here is the get endpoint, right? We want to get the value, the data of a person. You want to get this information. But for that, since you want to ensure that there is a person there and you need to create this expected results, that's why you create your own person there. Because like you could also use the real data with some fixture data. You can say, okay, in the database there is an Arman, but you can't be sure. What if someone else deleted it? Or what if there are multiple Armans? Or like
God forbid.
Yeah. So for that, it is good to always create your own person and then do the tests with that. And there is another approach. Like when you are done with your tests, sometimes like developers truncate those information as well, so that the database is like there is no race conditions or there is no data corruption. So these are approaches, but it makes sense to create a person first and run your tests. And at the end of your test, you just
delete the person.
Delete the person. Yeah.
Or clean the database in any way you can.
Yeah. So here, that's why we first create a person. And then when we create this person here, we call the person backend endpoint, and then we set the response body to the created user, the Maria user created. And then now I want to fetch the data. So actually here, what I try to test is this endpoint. But for that, first, I had some steps. I needed to create a user so that I can test, I can fetch that person's data correctly. So I fetched this data. I created a new endpoint here. That's kind of important because what we were doing here was only rendering the person's data. And render means it is rendering to a view. It's rendering to the HTML. So if you are writing endpoints for another application to use, it could make sense that you have a format or you just return the data itself. So I created another endpoint for us so that we can compare the result better. So it is only returning the user value back. It's not rendering the data, but it's returning me the user's data. So here, I again check for if it is returning 200.
Request.
Yeah, success. That should be this. Anyways, and then here comes the important part. I am checking the response of the fetch API call with the one that I created. So first, at the beginning, I said, this is the created user that I had. And also, this is the one now I'm fetching. So I can compare these two. That I know that at any given time, when I create a user, when I try to get that user's details, I don't have any data inconsistency. But here, if we would have the comparison with is, because this one is checking like if Maria user fetched is Maria user created. What would happen? Dun, dun, dun,
Should work.
dun, dun, dun. Didn't work. Why?
Values are deeply equal to each other, but they're not the same, is an error message that we get. So think about it. You are deeply equal to something or someone else, but you're not the same. It's kind of a, I don't know, philosophical question or philosophical statement, right? Unfortunately, in programming, it makes sense. It says if you check every single value inside Maria user fetched with Maria user created, they're exactly the same. However, these are different objects. These are different objects in memory. The just values are the same. They have the same ID, they have the same age, same meetups, same name, but they're not the same. They are different objects because there are two different variables. If you look at it, Maria user created is on line 30, is a different object than Maria user fetched, which is on line 41. So they are different objects. And this is not okay in terms of testing because maybe you're looking for an exact match, like that object to be exactly the same. T.is is ensuring the two things that you compare are exactly the same, the exact same object in memory, the same same reference. That's why here it doesn't make sense to use T.is because we have two separate objects, the one we created and the one we fetched. That's why we're using something else called deep equal. So T.deep equal is the way to compare two objects. If you have numbers, you can use T.is. For primitive objects, you can use T.is. For complex objects or arrays, we use deep equals.
Okay.
Which is, another syntax that you need to learn. Again, in another testing framework, this is completely different. So this is just what we use with Ava.
So here, another test I wrote is for checking my delete endpoint. So for that, sorry?
What is T.plan?
Yeah, that's good.
I think we're going to talk about it in a little bit.
I can talk now. Okay, so it is normally when you write your code, there are some cases that your code exits at one point. For instance, I called this API, but it never responded back to me, and I got let's say a timeout. Since this is waiting for it to be executed, until it is executed, it will never come to the next lines. So there will be a timeout, but maybe my test should fail or would fail if it would be executed. But it doesn't say anything because somehow I got a timeout. Or it could be that like in multiple conditional cases, we are expecting different results. So that's why we say I'm planning 3 assertions here. So I will compare 3 things. Like one is this delete response status is 200 and it is okay and it's fetched. So how many assertions you are checking for, you write that. In any case, if this assertion didn't even write, your test won't fail, but it won't be according to your plan. So this ensures that this will also fail because it will tell you, you planned for 3 and it didn't work. So if we would do this, let's say, if you would say 4, but we only check for 3, it would tell us you planned for 4 assertions, but you just got 3.
This is important in checking branches, if and else cases, because if you're, for the get temperature example, you might say, if the temperature is over 35, T dot is sunny. If the temperature is lower than 35, T dot is snowflake, right? In the end, at any given time, you can only have one assertion. It's either snowflake or the sun, right? You don't have 2 assertions there. If you have 2 assertions for any reason, then that means your code isn't working. So T.plan 1 in that case makes sure you get only 1 assertion, whether it's the weather is over 35 or lower than 35.
Okay. So delete a person. For that, we again create a person, and then we are calling the endpoint for deleting with that created user's ID. And afterwards, we delete it, and we check if our delete call was successful. So we do it with 200 again. It's the server standard status code. And then we check the response. Okay, if it is true, you can do only one, but I did both. So you can see both examples. And then now here, I try to get it again. This is the way that I can ensure that this data is really deleted. Because when I delete, my endpoint tells me, okay, I deleted. But what if it didn't really delete? How can I check it? I can try to reach it again. And if I get a 404, it means
that
the user is not there. Yeah. And for that, of course, you need to update your endpoints. So this is again test-driven development. So we didn't cover before, if that user was not there, we were trying to render it still. But if the user is not there, I should just send the status code as 404. So this is the way that you improve your code, and you covered those cases as well to improve. Okay, so we will write code now. Okay, we will.
Finally.
Yeah, finally we will write code. Okay, so let's see like what is missing actually, because we had our test coverage. When we run this one, it gives us some lines that are not covered. Of course, Meetup, I left it for you. You can do it. It's zero coverage, but I'm trying to cover person JS now. So there I can see some of the lines which are not covered, but I'm at 79, let's say, and it's not so bad. So if I cover more, this will become even better. Okay, so I go to person JS in roots, and then I'm checking this one. So what does this one do? It is, you call this endpoint with a user ID, and then with the meetups endpoint, it gets the user, it gets the meetup, and then it calls attend meetup function. Let's check what this one is doing. So it is adding the meetup to the meetups of the person. Also, it is adding the user to the attendees of the meetup, and it's just saving them in the database. Okay, so to be able to test that, like I should start with test, and I can say user can attend to a meetup, right? Like, let's close this for now.
This part is pretty important because this is going to be the majority of your homework. We will ask you to test the complex interactions that you have in your applications. And as an example, we have the user attending a meetup. So make sure you get this right.
So what do we do? Like, what do we need now? The test itself says, I need a user. So let's start with the user first. I can start with the with Anya user, and then the data of it. Age of it, let's say 25, and then meetups. At the beginning, let's say she didn't have any meetups that she attended before. And then let's create a meetup as well, because a user will attend to a meetup. So I need a meetup. For these, you can always go to your models. What do I need? I need name, location, and attendees. So you can go back and check name. So let's say JavaScript Crash Course 2019. And location is Wayfair this year. Okay, I need to set that. And then attendees. And let's say no attendee so far. And then, of course, I should create this user. This is just the data now. I should call the endpoint to create this. So create Anna, I can say, and then I will start calling for await request. And then this is calling our application with post. And what is the endpoint to create a person? It is just, we can do like this. Person. And we just give the data. We send the Anna to it. And then this is just the request, of course. This is the response of the request. So. And how can, like, the response is in the body. So I should reach the body. Maybe we can even console log this. Okay. This is even better. So I ran this so far. Let's see what it says. It will fail, of course, because there's no test now, but so it gives me a huge data, right? Because this is the request response. But what I need here is the body only, because in the body, I see Anya's person data. So if I simply go and say const created Anna, or Anna user maybe, because she became a user now. This will be it. And now if I log this, I just got this data, okay? Only the data that I needed, the user data. It's the same thing for Meetup. So we can say create Meetup response, and then we say await request app. And what is our endpoint for creating a Meetup? Is it a get or a post? Post, yeah, perfect. So as I said, you can always go and check what was my Meetup creation endpoint. So what is that? Yeah, it is Meetup. So I just say Meetup, and I send the data, which is here. And we do exactly the same thing. Let's say Meetup created, or created Meetup. The naming is hard. And then we just do this. Okay, so far, what did we do? We didn't do much. We just did half of the sentence. The sentence was a user can attend to a meetup. We created a user, we created a meetup. But we didn't so far attend. Like we didn't call the attend function yet, that endpoint. So if so far you have any problems, you can ask our instructors to help you. Okay.
Any questions? What questions do you have for us? Did everybody follow up with the test? Obviously, we're going to share the code afterwards, as we always do. But it's still good practice if you follow and try to run these yourselves, because you're going to run into certain issues, and we can help you out when we're all here.
Yes.
Thank you.
So now the next step is to do the action of attending. We already have an endpoint here for attending, right? So this time I need to call this endpoint with certain parameters and then create this, like calling this attending function. So next is, we can say like create. It is good to write comments, by the way, sometimes, and create meetup. And then now what we do is attend like Anna attends meetup. So let's say or attend meetup response is again calling our app with this route, right? So as you can see, this route is a bit different because it has an ID in it. So what is this ID? It is the ID of the person. Because as you can see in the code, when we were thinking about it, we said this ID is the user, and in the body, I will get the meetup. Is this part clear? Because as a person, you attend to meetup, and in the body, you get the meetup that you will attend. And here in the post request endpoint, you have the person's ID.
In the URL.
In the URL, yeah. So for that, we can use this fancy quotes. And then if you write it like this, it's parametric. So you can use any dynamic data there.
So make sure to note the backtick in the post function call. It's not regular quotes. It's called the backtick. It's difficult to do on international keyboards. It's really easy to do on English keyboards. That's why I recommend you to switch to English keyboards on the layout. It's built for coding, or coding is built for English layouts. But it's backtick, and when you use backtick instead of regular quotes, then you can actually use variables in your strings with this special syntax of dollar and curly brackets.
So now I need to use Anya's ID, because I already created Anya, and in the MongoDB, there is an ID, and I'm getting that ID to send it to my request, like to set it to my endpoint, actually, my URL. And then what do I send in the body? This time I should send, like before that I was sending some data. This time I can go and check what this is looking for again. As you can see, it's looking for a meetup. And then here I can also check how does it do. So it is pushing the meetup to the array. So there, let's say we say meetup.
And this time it is the meetups ID.
Created meetups. Created meetup. And then its ID we send.
So in a sense, this is what you're all doing with manual testing, like axios.get, axios.post. Whenever you're creating a user and you're adding a user to a meetup or whatever your application requires, you're always doing it manually in the browser, right? You're calling axios.post and creating a resource, refreshing the page, seeing the ID, putting it into another function call, axios post call, and we're just automating it.
And this is what we should check now, because our test is checking for, like specifically checking for if a user can attend to a meetup. And this is the call that we should check if this was successful. So how do we check that? We say T is, and then we have the attend meetup response, and then we have the status of it, and then we check if it is 200. Okay, so if we run this again, or we don't have to run, but it's reruns anyhow, then we see that user can attend to a meetup.
We have a question.
Do we need to check if ID of the user is inside meetup's object in here?
That's a really good question because we only checked the response of the service now. But the next step, we should ensure that it really added there. So we should check two things. As you mentioned, we should check if user has this in its meetups or in their meetups. And also we should check the meetup if the meetup has this user in the attendees. This is the approach you should have while testing, because if you just say, okay, I called this endpoint, but what if this somehow didn't work? Then you didn't check if it really did the job. So that's the next step we will do now. How can we do it? Like, how can we do that? Like, now the user data is changed. The user's data now has meetups. It was before, when I first created, was no meetups. And meetup didn't have any attendees. Now I expect to see in the meetups this meetup, and in the attendees, this Anya user. So the next step we should do is, when we create anything, we check again. We fetch this person again, and we will fetch the meetup data again. And then we will see if this really changed. Okay, does it make sense here now? No? Okay, so let's try and see. So far, we just checked that our web service was called, and it said, I am called, it is successful, but I want to really see that meetup inside the user. So for that, I check again, like altered user, because the user is not same anymore. I can say altered Anya, because I expect Anya to be changed now. She didn't have any meetups, now she has meetups, or one meetup. So the request is the same, exact same thing for fetching. So it is await request app. This time I do the get to get users data. And the endpoint for it is person. Oh, sorry. By the way, you can also check if this one is returning any value. That's also possible. Let's check the root of the person. So this already gives us the user. How we did here, after attend meetup is called, this endpoint is giving us the user. It could also give us the meetup, but now it only gives us the user. So for that, it's obvious that I don't need anymore to call and get the user, because it's giving me the altered version of Anya. So I don't need to do another call. So I just do this. And then I check, should I do is or deepakul? What do you think? Yeah. So altered Anya's meetups. This is an array. The first elements, ID, should be the created meetups ID, right? Does this make sense? Because I called the endpoint for attending to a meetup. There were lots of executions there. User has now meetups. Meetup has users, and it returns back me the user's data back here. This endpoint returns back me the user. And then I'm checking if this user, the altered user, has this meetup, the same that I aimed it to be. And let's run it. Yeah, it passed now. So,
wow.
Yeah, this as well. We can check altered data to see it a bit, you know, how the data was. So here you can see Anya has a meetup, which is Wayfair, like at Wayfair, with the name of JavaScript Crash Course.
This is amazing. It's crazy.
Very crazy, yeah.
And it's running whenever you're changing any line in your code base. So now you're covered. Now you don't have to worry anymore that your functionality of attending a meetup will ever break. At least you have this test covered. It looks ugly. It is a lot of work to write. If you see what we did here, it's very repetitive. We're almost copying and pasting code and doing the same things over and over again. This is why developers hate writing tests. If you see a fellow engineer, they hate writing tests. And that is kind of okay. I mean, if you have to write thousands of these things for everything that you do, you're also going to hate them. That's fine. But we still have to do them. That is unfortunately the only way to get 100% quality or code coverage in our applications. And we hope that we will have a lot of quality. And
let's check the code coverage.
Oh yeah.
That's the good. It was like
79, I guess.
Yeah, something like that. Dun 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 dun. It's already a lot. No, 88. Because by creating the meetup, we already covered a few lines in the meetup.js. It was 0%.
Yeah.
But just by testing it through attend functionality, it already started being covered.
So again, this is a great way of making sure your applications have a certain level of quality. That is why the homework for this week is, as you would guess, to write tests for your application, for all your routes, for creating your routes. You can copy paste code, that's fine. There's going to be a lot of code that you have to write this week, mostly copy paste stuff, and not very fun to write, but it's a must to ensure we are doing our jobs properly, that we are, in the very sense of the word, we are software engineers. Without testing, you cannot be a software engineer. So you will do this for all your routes and all the complex interactions between your objects. And again, try to get 100% code coverage in your code coverage table here. It's difficult. It's very difficult. You're going to be pulling your hair apart. That's why I don't use hair anymore, because it's very difficult to keep it when you're developing code. It's going to take a lot of time. Start the homework as soon as possible. It's not a lot of complexity. You won't have to invent certain things to make this work. It's a little bit repetitive work, but again, it's very useful and very required. I don't know how something can be very required, but it's very required to do so. Try to get 100%. This is good marketing. Like, only get the 3 lines that are 100%. No. The best homework will the best homework will have 100% on all of the cells in this table. However, again, that is very difficult to achieve. If you can't achieve 100%, there's going to be some cases where you are like 97.68%, and whatever test you add, it won't go up to 100. That's fine. Don't beat yourself over it. That's okay if you cannot achieve 100%. But again, that is our goal. And then you're going to find the minimum threshold value that your application should have as the minimum code coverage that we have to have in order to develop further functions in it. Still, of course, you're working on your applications, right? You're working on your business logic, adding more functionality and everything. And I expect in the coming weeks, when you add more and more functionality to your applications, you also add some tests. So everything we're doing is adding on top. You now have a new responsibility. Whenever you're adding a new functionality, you also need to have the tests for it. Hopefully, in 2 weeks' time, you're going to achieve 100% code coverage for everything for the graduation event. I mean, I'm going to break it to you. It's a great satisfaction to see all the green boxes here. It's like, yes, I did. Finally, everything is green. Everything is like 90% and up. And I hope you'll feel that as well. In the previous years, people were really celebrating it. In the beginning, it's like 60%. It's not going up, 60, 70%. And then once you hit like 90, 95, or 100, it's a great satisfaction. So if you have OCD like me, it's going to help to see 100% everywhere. And it's going to drive you mad if all of it is 100, but then there's only one file that is 99.95%. This happened to me. I killed that file. I mean, you reject it, right? You write something else to make it testable. And we're over time. This is the last thing that I'm going to tell you. I kind of like blew your minds out last week with the introduction of meta services. This week, it is about testing. Are you ready? Are you bored? Was it too much? No? Anyway, okay, no, I'm not gonna do it. Maybe next week. I was gonna talk about further testing scenarios, but I think this is enough if you covered this. I'm gonna see you next week. Any other words?
No.
Are we all good?
We are over time. Yeah.
We will send out the survey. Please fill them. It's really important in how we shape our lectures and our food. As a result of last week's surveys, we had bowls plus wraps today. So, because that's what you wanted in the feedback form. We're going to incorporate those in the future as well. We'll see you next week. There's going to be testing. We're going to have another software engineer from UNU. Next week is front end. We're going to have another software engineer or two, maybe, from UNU talking about front end. Anya Pavlova will be here. The person that we created today, we created for next week. She's going to talk about.
Attends.
And she attends the meetup. Yeah. She sometimes attends the meetup. She's going to attend next week. All right. Please keep your homeworks in your minds. Do them before next Tuesday so that we can have a chance of review. And write to us if you have any questions. And see you later.
See you. Thanks.